What's up, you freaking geniuses? So in this video, I'm going to teach you about the differences between perpendicular and angle bisectors in a triangle. And I'm also going to teach you about points of concurrency. Okay, so let's start with angle bisectors. So a bisector is just a line that splits another line or angle in half. So this triangle over here obviously has some angle, so an angle bisector just cuts that angle in half, right? So then that way this angle is equal to this angle. Now, if we draw out all the angle bisectors, right, so this one would be something like that. Okay, we can extend that one, and then this third one, we can draw something like that, right? So you can see that they all intersect at a certain point. And this point right here is called a point of concurrency. So points of concurrency occur when three or more lines intersect, like this. Okay, and the point where angle bisectors intersect is called the incenter. Right? Now, let's talk about perpendicular bisectors. So again, a bisector cuts a line in half. So if you wanted to find the bisector of this side of a triangle, you'd first have to find the middle of the triangle. So we'll just say it's about here, okay? And then you would draw a straight line that creates a 90-degree angle with that side. Now, we can do the same thing down here. We can first find the middle of the triangle. So maybe about here, and for this triangle, we can say it's about here or something, right? So again, you would just draw a straight line that creates a 90-degree angle with the side. So same thing here, straight line that creates a 90-degree angle with the side. And let me clean this up a little bit just so we can see that these three lines also come to the same point, right? They all intersect at a certain point also. And the point, again, where they intersect is called the point of concurrency. Okay, and the point of concurrency for perpendicular bisectors is called the circumcenter. Okay, now the incenter of a triangle is always going to be inside of the triangle, somewhere inside the triangle. And the circumcenter of a triangle will either be inside, on, or somewhere outside of the triangle. And you can see that a little bit easier if we use an obtuse triangle. Okay, because here, if we draw the angle bisectors, just approximately where they are, you know, something like that, okay, you'll see that they'll, again, intersect at a certain point right here. This is the incenter, and it's inside of the triangle, right? Now, if we draw the perpendicular bisectors for an obtuse triangle, okay, so again, we have to first find all the midpoints, so middle's there, middle's here, and the middle's about there. And then if we draw that straight line, and I'm going to have to extend them because you're going to see they're all going to intersect, right? These are 90-degree angles approximately. And then this last side, you can see if I extend it to the inside, I'm not going to intersect with either of these lines, right? So I have to extend it to the outside, and we still have our 90-degree angle. Okay, so then you can see that the point of concurrency, the circumcenter, lands on the outside. Okay, now the last thing I want to mention is the distance from the incenter to the sides of the triangle. The shortest distance will create a 90-degree angle, okay? So the distance from the center to here, again, is about a 90-degree angle, and then same thing to the bottom side right there. Now, if we look at this triangle over here, again, you want to find the shortest distance from the incenter to the side of a triangle, right, creates 90-degree angles. So from here to here, that's a 90-degree angle, and then from here, we can draw a little straighter line, straight down, that creates a 90-degree angle. Okay, so it's really important that you don't confuse these distances with perpendicular bisectors. Okay, so again, perpendicular bisectors specifically hit a side of a triangle at the center, at the midpoint, right? At the midpoint, at the midpoint. As you can see with these, the midpoint of this bottom side over here is like over here, right? And you can see that this distance drawn, this perpendicular distance right here, is not at the midpoint, okay? So this is not a perpendicular bisector. This is just a perpendicular distance. And I want to stress that point because these distances are all the same, okay? The distance from the incenter to any side of a triangle are all the same. However, when we look at perpendicular bisectors, all the distances are not the same, right? You can clearly see this length and this length are really long, but then this length is really short. Okay, so those are the differences between just a perpendicular length and a perpendicular bisector. Okay, so now I just want to go over a few quick little examples here. So these instructions say, name the points of concurrency of the angle bisectors. All right, so looking at 15 over here, again, an angle bisector splits an angle in half, right? So we have this angle up here, so that means this is the angle bisector, right? Same thing down here, you can see we have this angle right here, which is a right angle, and so this is the angle bisector. And same thing over here, it tells us that these two angles are the same, so we know that this line in between them is the angle bisector, okay? So then you can see all 3 points meet right here at C. So C is the point of concurrency. All right, let's go to the next one. So again, let's find the angle bisectors. So for this angle over here, you can see that this is the angle bisector. For this angle over here, again, you can see they're the same, so we know that this line in between them is the angle bisector. And then up here, you can see that for this angle, the angle bisector is not drawn, right? Because this line is just a straight perpendicular line that just goes straight down here. So this line really isn't anything, it's just the height of the triangle. So the actual angle bisector of this angle would be something more like along this line over here. Okay, so then you can see that the 3 angle bisectors intersect at this point over here, Z. All right, for this last example, we just have to find the value of x. So as you can see, we have our angle bisectors drawn right here, and they all meet right here. And then you can see that we have these lengths, right? These perpendicular lengths or distances. So you can tell that they're not perpendicular bisectors because, again, a perpendicular bisector along this bottom line would be in the middle, right? So it'd be, somewhere over there. Okay, so since we know that these are not perpendicular bisectors, these are just perpendicular lengths associated with this point of concurrency, right, the incenter, then we know that all these lengths are the same. All these distances are the same. So if we need to find what x is, well, we know that this distance is equal to this distance, right? So we can just set this, 4x minus 1, equal to this little expression, 6x minus 5. Now to solve for x, we just need to get them to the same side, so let's move them to the right. So here we can subtract 4x, those cancel out. We get -1 is equal to 2x minus 5. Here we can add 5 to both sides. Those cancel out. So here we get +4 is equal to 2x, right? So then here we can see that x is equal to 2.
So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.